Welcome to The Explainer. Today, we are tackling something that might seem small, but is absolutely foundational for any data scientist stepping into an MLOps role: mastering your Python imports. Getting this right is really the first step from writing an experiment to engineering a real system. Let's be honest. Does this look familiar? You fire up a new Jupyter notebook, you're ready to get to the good stuff, the modeling, and you just start throwing imports at the top of the file. Whatever you need as you think of it. We've all been there. And you end up with a block of code that looks a lot like this. You've got pandas next to sys, next to your own custom utils. It's a total jumble. And hey, let's be clear, this code probably works, but working isn't the same as production ready. This is exploratory code, not the clean, professional engineering that MLOps demands. So before we fix this mess, let's just take a quick step back. What even are imports? Well, simply put, they're how you pull the power of other code into your own project. Whether it's Python's built-in modules or powerhouse libraries like NumPy and scikit-learn, imports are your gateway to a massive ecosystem of tools. All right, so how do we go from that chaos to some clarity? We turn to a community standard called PEP8. Think of it as the official style guide for Python, and it gives us a super simple, really powerful rule for organizing our imports. The PEP8 standard is just beautiful in its simplicity. You just organize your imports into 3 groups, always in this order, and you put a blank line between each group. Group 1, Python's standard library. Group 2, any third-party packages you installed. And Group 3, your own local code. That's it. This structure immediately tells anyone reading your code what your dependencies are and where they're coming from. So let's look at that before picture again. Here's that disorganized mess. See? Pandas, a third-party library, is all mixed up with sys, which is a standard one, and our local myutils. It's hard to scan, and it just doesn't look professional. And now, look at the after. So much better, right? It's just so clean. Standard libraries first, then a space. Your third-party libraries come next, all alphabetized using those common aliases like NP and PD. Then another space, and finally, your local imports. It's organized, it's predictable, and it is way more readable for you and for the rest of your team. Okay, now that we know how to structure the imports, let's talk about what to import. What are those essential tools that really form the backbone of pretty much every data science and MLOps project out there? For most of the work you'll be doing, your starter kit is going to be these 4 powerhouses. You've got pandas for all your data wrangling, NumPy for the heavy-duty math, a good visualization library like matplotlib or plotly to actually see your data, and of course, scikit-learn for the bread and butter of your modeling work. And getting all these tools into your project is super easy. If you use a modern package manager like UV, which is incredibly fast, by the way, you can install them all with just one command. This makes sure everything lands correctly in your project's virtual environment. All right, let's move on to a few common traps that can cause some really subtle bugs and big headaches. Nailing these is a huge part of writing robust, production-level code. Okay, this one is critical. It's called name collision. Imagine you import a function named load from one library, and then you import another function also named load from a different library. You know what Python does? It doesn't throw an error. The second one just silently overwrites the first. This can lead to some incredibly confusing bugs where you think you're calling one function, but you're actually calling another one entirely. Thankfully, the fix is so simple. On the left, you see that risky code. It's totally ambiguous which load function gets called. But on the right, we use an alias with the as keyword. We just rename them to load1 and load2. And just like that, the problem is gone. The code is now explicit, it's safe, and everyone knows exactly what's happening. And here's a really important tip for security and just general stability. An import statement isn't just a passive declaration. It actually runs the code in the file you're importing. This means a malicious package could run bad code the second you import it. So the rule is simple. Always import from trusted sources. Okay, but even when you do everything right, you are eventually going to run into the dreaded module not found error. It happens to all of us. So let's quickly talk about how to troubleshoot it, like a pro. So you type import pandas, you run the cell, and you get an error saying the module can't be found, even though you're positive you installed it. What is going on? Well, I can tell you 9 times out of 10, the issue is that your notebook is simply not connected to the correct Python environment, the one where you actually install the package. So, your very first diagnostic step is to run these 2 lines of code. This will print out the exact file path to the Python interpreter your notebook is using. You can then look at that path and see if it's the one inside your project's virtual environment, like in the .venv folder. And if that looks right, your next step is to check sys.path. This will show you a list of all the directories Python is looking in to find modules. You need to make sure that the site packages directory of your virtual environment is actually on that list. If it's not, Python's never going to find what you installed. Usually fixing the interpreter automatically fixes this too. And that really brings us to the big picture here. Mastering your imports, it's about so much more than just following some rules. It's a fundamental mindset shift. It's about moving from just making code that works to engineering systems that are professional, reliable, and maintainable. So the question I want to leave you with is this. Is your code just working for you today, or is it ready for your team to depend on for years to come? The answer, believe it or not, starts right at the top of your file.